In this video, we continue our notes on section 1.6 on the second derivative. So the video we just saw was example 1 from this section, looking at a rabbit population. We asked whether or not that rabbit population increased or decreased, and we also looked at how the rate of change, or the growth rate, changed, whether it increased or decreased, over our time intervals. So now we're going to formalize the idea of a second derivative here in this box, and then look back at our first example to make sense of a second derivative. So in this box here, let's fill in the blanks. So the first and second derivative. So if we start with a function y equals f of x, then we've seen before that the rate of change of f of x is given by f prime of x. So looking at the rate of change of a function, we include this prime symbol, f prime of x, also called the first derivative. Now, if we want to look at or consider the rate of change of f prime of x, then we write that as f prime prime or f double prime of x. And we call it, which is called the second derivative. So again, looking at a function f of x, if we consider the rate of change of that function, we write f prime of x. It's the rate of change of f. So if we want to consider the rate of change of f prime of f, then we just slap on another prime symbol, f double prime of x, again, which is called the second derivative. So now let's look back at our example with the rabbits and see if we can put some of this new notation that we learned on these questions. So in question 1, we're looking at increasing or decreasing of our function f of t. So what we can observe is that if our function is increasing, then the rate of change is positive, which would mean that our derivative rate of change is bigger than 0, is positive. So in this case, when our function is increasing, our first derivative is positive. So if we want to talk about what interval our first derivative is positive on, we could say f prime of x is bigger than 0 on the interval from 0 to 10. So pause the video and see if you can write notation for what f prime of x is doing on our interval where we are decreasing. So if our function is decreasing, our rate of change, f prime of x, and actually we are looking at t here, so let me make sure I'm using the right notation, f prime of t. So f prime of t will be negative if our function is decreasing. We saw here this never happens, so we'd say f prime of t is less than 0, never. So then now when we talk about if our rate of change or growth rate is increasing, then that would mean we're looking at the second derivative, the change of the rate of change, the change of f prime of t. So if our growth rate increases, then that would mean our second derivative is positive, just like we saw if our function increases, the first derivative is positive. So in this case, if our rate of growth is increasing, our second derivative is positive. And we saw that indeed it is positive on the interval from 0 to 5. And then finally here, if our rate of growth decreases, that would mean our change of our change is less than 0, is negative. We're decreasing our rate of growth. And we saw that's the case on the interval from 5 to 10. So let's summarize some of these findings in this box at the bottom of our page here. So in this box, we're relating the derivative and the shape of a curve or shape of our function. So let f of x be twice differentiable. So that just means we can compute the derivative once and then twice. Recall, we can't always do that for a function. For example, if it has a corner or a cusp. So we're assuming we can compute a derivative and a second derivative of a function. So if f prime of x is bigger than 0 or positive, then f of x is increasing. And that would mean the graph of f rises from left to right. Like this, we can think of a graph like that. Similarly, if f prime of x is less than 0, then f of x is decreasing. And the graph of f falls from left to right. So now let's consider what happens then with our second derivative. So if we go back to our original graph here, just to recall, on this first interval, our second derivative is positive, so I'm going to write that down. F double prime of x is bigger than 0. And on the second interval, f double prime of x is less than 0. So what do we notice about the differences visually of these two parts of the graph? Is there a way that we can describe them? So you might have seen before, this first part of our graph is what we call concave up. Second part of our graph is what's called concave down. So if there were to be water that falls in here, in a concave up graph, the water would stay. But if there was water that falls on a concave down graph, the water would all fall down. Okay. So using that language here, we see that f double prime of x is bigger than 0, then f is concave up. Such a function is shaped like a right side up bowl, we could say. You might want to draw a little picture for yourself just to help you remember. Concave up. And the second derivative, f double prime, is less than 0, then f is concave down, which is like an upside down bowl. If you want to draw a little picture for yourself, concave down. Some people use cute little cartoons to help them remember, and specifically to help them to remember the sign of the second derivative and whether or not it's concave up or down. So the little visual looks like the following. So if we have positive second derivative, then we have a concave up graph. If we have a negative second derivative, then we have concave down. So positive, it's like a happy face. Negative, it's like a sad face. So that's one way to kind of remember the different shapes of our graph based on the second derivative sign.